G'day there, you're watching the Aussie BIM Guru, and today I'm going to show you how to put together views from the sun using Dynamo. So they look a little bit like this. So essentially it's a time of day looking at a target from the sun's perspective. So they're a bit of a preliminary design technique that we use quite a lot in architecture in order to just see what we're going to be shading, or maybe a view analysis. So we don't necessarily have to look from the sun, but today we're using the sun. It's a very basic technique, so we don't use it super late in the design process, but we will use it in things like design reports in order to show the client a simple version of what the sun can see at a particular time of day. So essentially everything you can see is in light and everything you can't see is in shadow at the time of day that the view is set to. So, calling on an old classic, everything you see the light touches. Sorry, a bit cringe. So the custom packages today that we'll be using is Ladybug and Genius Loci. So Genius Loci we're using in order to establish the locked or unlocked perspective of a 3D view, because sometimes you may want to lock that view once you make it, just to make sure that the user can't disable the view or move it around, because it really is from a very precise point of view. And Ladybug we're just using to establish the sun ray directions. So we've used that in some past packages, so you may recall seeing Ladybug in a feasibility series I did, but you'll need to download it from the package manager in Dynamo, same as any other package. But you will need to get a weather file for where you are in the world from Energy Plus. So search for your city and download the weather file in EPW format, because we will be feeding that into Ladybug. And we're using Dynamo 2.0.3 today. So I think this will work in most versions of Dynamo. I'm not sure how Ladybug performs in version 1. I don't think it performs as well, but you can always try it out if you're not using 2 yet. I recommend you follow my version if you can. So without further ado, let's just jump into our model. So this is our model. It's got a site around it as well. I've just cropped it with a section box. But essentially we'll be trying to set up views that look a little bit like this. So what I've done is just pre-prepared a view template that just applies the graphic settings. It's important to note that shadows are off, because we're essentially seeing everything that light should be touching, so you don't need shadows on. That way we don't have to actually worry about the true time of day in Revit. So we don't have to worry about setting it using Dynamo either, because there's really no need to, because everything is going to be light. So we'll pretty much just jump straight from here into Dynamo and start building our script. So I've just made an empty script. Make sure that you set your view to like a non-perspective view, so maybe just pick like a floor plan or something like that, because Dynamo can't run whilst you're in perspective. Just an interesting little behavior of it. So we're going to be heading towards this view. This is our destination, so it's going to be perspective by target point element. And the reason I like to use this one is because it gives you quite a precise way of positioning your camera. So essentially we're going to get an eye point. So where are we looking from? A target point. What is our element that we're sort of focusing on? The name of the view, and whether we want to isolate just the element that we're focusing on, which in this case we don't. But sometimes I like to use this one because sometimes maybe they're using a building mass and they just want to look at their mass from the sun perspective, so maybe they do just want to isolate that mass. So this is the best way to generate perspective views, I find. Anyway, we're going to go back to the start of the process. So we're going to set up our sun rays using Ladybug. So I'm just going to move all of this off to the side. So what we need to do is get the rays of the sun from Ladybug. So we need to get our EPW file, so we need a file path to do that. So I'm just going to go file path, browse, and we'll just browse to our weather file. In my case, I'm working with Sydney, that's my hometown. We need to import location. Well, actually, the model I'm using is actually sited in Adelaide, funnily enough, so technically it's not true and correct site information, but I'll use Sydney anyway. Not too different. Anyway, so we need to get our sun path from there using Ladybug. And we feed in our location from our EPW file here. But what we need to do is give the hours of the year that we're working with now. So we need to get these HOYS, or hours of year. So we're going to get our calculate hours of year node from Ladybug. And we're going to feed that in here. So now we need to build our range of time that we're working with. So we're going to get some integer sliders. You've probably seen me do this a few times before using Ladybug. But essentially we just need, in this case, the month, the day, and the hour start and hour end, because we're going to set up this script so that it can do a time range. So you can do more than one view at once if you like, because we often generate a view from 9 till 3 for every hour. So it's good to be able to set a script up that can just do it all in one hit. I'm just going to set myself to the most common day and month that we test, which is the 22nd of June, the winter solstice, because that's usually what day I guess the shadows are at their deepest. Anyway, we'll go month, day, and then we need our hour, but our hours are going to be set up as a range. So we're just going to do this syntax here for start and end with a step of 1. And essentially we just want to get our hour start and our hour end. So hour start, and I usually just do this between 1 and 23. And we'll just start at 9, and we'll set up an hour end as well. We're going to run this through Dynamo Player at the end. So I'm just going to name these as I go, and then we'll just set our inputs at the end. Okay, so I start and end, hours. Okay, so what we'll do is just run at that point, and we should get a whole bunch of site data. We're going to turn off the sunpath preview, and what we need to do with that is actually get our vectors. But we're going to reverse our vectors because we're going to be looking towards the site instead. So we're going to reverse our sun rays because we're going to start at our focal point and then push away to find our target, our eye point essentially. But we should have a list of vectors at this point. So we have 7 vectors. So that's great. So what we need to do now is we need to establish our focal point and our focal geometry. So in this case, I'm just going to pick like a wall or something simple in order to be my focal point. So let's just get a select model element. And we're going to use this element to establish the focal point as well by processing its geometry and setting its center point as the focal point. So I'm just going to pick this wall in my model. And then we can go back in Dynamo from here because we have all the inputs we need from Revit. And we'll just say this is our focal element. And we're going to get its geometry. So we need element geometry. And this will essentially let us find the center point of this element. So we're going to go and process out anything that may not be a solid. Because occasionally with elements in Dynamo, you can get things like model lines. And if you just have even one single model line in a group of solids, you can't bake them into a single solid. So we need to process all these things out. So we're going to check if the object type as a string contains the word solid. And this usually will filter out things like surfaces and lines and points. We're going to ignore case as well because we don't mind if it has a capital. And then we're just going to use a filter by Boolean mask at this point. So we're going to filter our geometry and we're going to mask it. Okay. And then we need to flatten first. In this case, we've just got a wall, so it's only one solid. So it's probably not the best example. I might pick a more complex element. Let's say this tree. There's quite a lot going on with this tree. And hopefully it won't crash out Dynamo if I use it. I'm just going to save my script before I forget as well. Whoops. Okay, let's just try running it and see what we get. We might get a crash. Hopefully not. Okay, so lots of geometry is quite complex in this element. You can see we have surface, surface, surface. We have zillions of surfaces, zillions of lines, and we don't have a single solid, unfortunately. So that's a shame. But you can see as a result, it filters all those rubbish things out. But obviously this isn't a good thing to pick for a center because it's all made up of faces. So let's just pick a stair, see what our stair contains. I don't know if stairs are just all solid as well. I believe they might just be all solid. Let's see. Yeah, it's just a solid. So I can't really find, I guess, a good element to test. But trust me that sometimes you will need to filter those out. Okay, anyway, so we're going to do a solid by union after that. So we're going to join, just in case there's more than one solid in that element, because some elements are comprised of multiple elements, say that tree that we just saw, for example. And then we're going to use this unioned solid to get its centroid. Essentially its center point, because this is our focal point for our study. Okay, I'm just going to move this just a little bit away. What we need to do now is we need to translate this point away by the vector of the sun that we're reversing. So we're going to do it by a direction and a distance. So as you can guess, our geometry is the centroid. Our direction is that reversed vector from the sun. And our distance is going to be in meters, ideally. So we're going to get a number input. And by default, I'll just set it to 200 meters. But I'm working in millimeters at the moment, so I need to convert this unit. So we're going to do convert between units. And in my case, because I'm in Australia, and we don't have to use a different system like Imperial, thank God, we're going to go from meters to millimeters. This way I'm working in my native units. And then I don't have to type in 200 million millimeters just to get 200 meters. Much easier for people to understand. That's my distance. So I'll just say target distance meters. So my user understands what unit they're expected to use. Okay, so from there, we're almost at the point where we can run this actual study, because we have our I points. So our I points are those translated points. Our target is our centroid. Our element is back here, which is our wall. We are going to be saying false for isolating the element. And it's important in this case that we have some things that are inputs of 1, some that are list inputs. So we need to set ourselves to a longest lacing, so that whatever elements are short lists get repeated for every other element that's being fed into the list. Okay, so what we need to do now is actually establish our view names, because we don't have names set up at the moment. So let's just set up a naming algorithm that can, I guess, establish a name set. So all these will need to have different names. So what's different about these views? Time of day. So we're going to use the hours to drive how our names are viewed. We're going to add a couple of strings just to add the optional prefix and suffix. So usually I tell the user if it's optional as well. And likewise, we can have a suffix. But by default, I like to make the prefix sunView by default. So at least there's something that sort of sets it apart when you make it. Okay, we're going to make a code block now to generate our naming algorithm. So we're going to go that we need our prefix plus, we'll just do a space dash space plus date. We'll do that plus just a single dash with no space plus month, which is again a variable, dash plus hour. So we'll do hour, but because we're always working at whole hours, we'll just do dash 00 space dash space, and then I'm wondering if we, yeah, we'll make it so the user probably should add a suffix. So what I might do is just prompt them to add study1 to make them think about their suffix a bit more. Okay, but essentially we need to feed in our prefix, feed in our suffix. We're going to get our day back from our hours of year. And I think we may need to convert these to strings. I'll just double check. Whoop, cat attack. Maybe not. I'll try it without converting to strings. Cat attack. Let's move him. So we'll grab our day back from here. Sorry for the distraction. So that'll be the 22nd, our month from here of June, and our hour. Our hour in this case is our range, because we want to create a range of names. So we're freezing down this view just to see what our names look like. So we'll add a watch node, just because code blocks only show you the last element in a range. So we want to see all of them. See how that looks. Sun view, 22nd of June, 9 o'clock. I think that's good. The only thing I might do is just add an underscore between the date and the time, so it's more obvious to the user where this break is occurring in the name. Much better. So I think that's really clear. I think a user will understand what they're looking at when they read that. Cool. So all we need to do from there is take our name, feed it in here, and you can see we're getting a warning here on this node. It's saying that it can't handle large scale geometry. To fix that, you just go settings, and we'll just go to geometry scaling and set ourselves to extra large. Okay. And from there, all we need to do is use that Genius Loci node in order to lock or unlock our view. So we're just going to do 3D lock or unlock. Okay, that didn't show up. Lock or, oh, there it is. Genius Loci is a great package. It has a lot of really random miscellaneous nodes, so definitely try it out. So we're going to take our 3D views and we're going to set our lacing to longest because we want to do this to all our views. And we're going to make a boolean saying locks. But I guess the way we want it to work is if you check the node description, it says use a boolean, false will lock the view. It'll be better if true locked the view, but it doesn't. So all we need to do to reverse that boolean is just use the not node. So that'll flip our true to false or our false to true. And essentially this is the script done. So this script should now work. But what we're going to do is we're going to run it through Dynamo Player. So I'm just going to, I wonder if I should test it here first or just take a risk. Let's take a risk. I'm going to go input focal element. I'm going to go input on my month, input on my day, input on my hours start and end, and input on my target distance, and also whether I want to lock or unlock my view. And that's pretty much it. So I'm going to run it through Dynamo Player just because I like to live dangerously. That sounded really nerdy. Dynamo Player. So we're going to boot up Dynamo Player, navigate to our script, and then run it through the inputs that we've just set. Oh man, got a little friend hanging out with me here. Say hi to Aussie. That's one of my cats. I've got two. So we'll go to desktop. We'll go to view from Sun. So I keep my scripts on desktop when I'm doing my videos. Not the best practice, but so shoot me. So we're going to go to inputs on the demo script and cross our fingers that everything works as planned. Ideally, it should show up somewhere down here when we create the views. So the annoying thing about 3D views in Dynamo is you can't assign 3D view templates to them. Such a pain. I think there's some really harsh workarounds you can do by going into the object classes that I've read about, but obviously for the average user that's not possible. So what I recommend is usually applying the view templates after the views are created. So we're going to go June 22nd, 9 till 3, but obviously we could change these if we wanted to. It's important to note your users can turn the time range around, which means it will, I think, counts down in the range instead, so it should still work even if they flip your time range. And if you just want 1 hour, you just set that start and the end to the same. But we're going to go 9 till 3. Our focal element, let's just pick this wall. We'll go, let's say we're going 150 meters away and we're locking our view. So I'll run my script. We should expect to see a set of 3D views, assuming everything worked. Great, it worked. Phew. So by default, there'll be no view template on them. So if you have a view template prepared, just shift select and apply your view from Sun template. And there we go. We have views from Sun, 9 o'clock, 10 o'clock, 11, 12, 1, 2, and 3. Cool. So we worked perfectly. So pretty much that's how you create views from Sun. So really helpful technique and a really flexible script that I think users will find quite handy in early stages of design. And it obviously saves them having to find a 3D point in a perspective, which takes ages in Revit unless you know how to do it properly. So that's it, nice and easy. So hopefully that helps give you another tool that you can use in your day-to-day workflows, and also shows you how to process view names and also how to work with Ladybug. So if you've got any questions or feedback, feel free to leave it down below. Always happy to hear if there's suggestions for future videos. I've actually got a few coming in, so there'll be a few new topics coming up that people have requested in the next few weeks. So thanks for everyone for those. And hopefully I'll see you in the next video. So if you're not following and subscribing already, feel free to do so. And thanks for watching. See you in the next video. Thanks. Take care. Bye.